Hi, my name is Grace, and today we're going to be talking about remote sense for NI power supplies, electronic loads, and source measure units for accurate measurements. A challenge in sourcing or measuring precise voltages is the effect that the lead resistance can have on the measurements that your DUT sees. Lead resistance is always present, but can become problematic when using very long, small wire gauges or using higher currents for testing. In a typical 2-wire measurement, the resistance of your leads is unaccounted for. So this results in a voltage drop across the lead and introduces errors in your measurements. NI power supplies, E-loads, and SMUs are equipped with remote sense, which is a 4-wire measurement setup designed to counteract those effects of the lead resistance. So these instruments feature 2 extra terminals on the output, which allow for this 4-wire remote sensing technique. And these extra terminals are connected directly at the DUT. With remote sense, one set of leads carries the load current, while another set of leads measures the voltage directly at the device under test. Here in our setup today, we have a couple of power supplies and electronic loads that are going to be sending power to our DC-DC converter, and the electronic loads are going to be acting as the load on our DC-DC converter. I'm going to go ahead and open up InstrumentStudio, and we can take a look at what remote sense looks like. InstrumentStudio is our software to configure and control instruments, including our power supplies, E-loads, SMUs, and a variety of other instruments. This is our free edition, which is going to be the equivalent to the panels you might see on typical box instruments. So here we are seeing a current step that we are showing on our DC-DC converter. We're starting at 10 milliamps, stepping up to 20 amps, and then going back down to 10 milliamps. You can see here on the voltage, this is a 1-volt DC-DC converter, that we're getting a lot of voltage drop here in the line. And this is without remote sense. If we go ahead and turn on our remote sense, and you'll see a huge difference in the voltage drop that we're seeing across our 1-volt measurement. So you can see here it's very minimal on our graph. You can also zoom in and zoom out on these to take a better look at that. So that's just a really quick example to show the difference that remote sense can have on these smaller voltage measurements and getting precise, accurate measurements. Thank you for watching.